Hi, I am Gianna Bancali.
And I am Dion Alfred Incargus.
Together
Together, we will discuss
and explain harmonic sequence. This would be the outline of our presentation. First, we have to discuss about definition of harmonic sequence. It helps readers comprehend what they could not. It also serves as much needed assistance, assisting readers to decipher unfamiliar terminologies and making sense of outside knowledge. Second, we have to provide different examples that are comprehensively explained and interpreted. Harmonic sequence. The harmonic sequence in mathematics can be defined as a reciprocal of the arithmetic sequence with numbers other than 0. For example, let's take an arithmetic sequence as 5, 10, 15, 20, 25, and so on, with a common difference of 5. Then, its harmonic sequence is 1 over 5, 1 over 10, 1 over 15, 1 over 20, 1 over 25, and so on. Take note, we cannot apply harmonic sequence formula if the equation itself is not harmonic. So how could we know if the equation is harmonic or not? We have to get the reciprocal first. It is just 11, 14, 17, and 20 because the denominator is just 1. So we're gonna be finding for common difference. So a sub 2 minus a sub 1, 14 minus 11 is equals to 3. It does share common difference, so therefore it is a harmonic sequence. This is the formula of the harmonic sequence. Example number 1. Find the 10th term of the harmonic sequence 1 over 8, 1 over 12, 1 over 16, and so on. So the first thing we're going to do is reciprocal. So it will become 8, 12, and 16. Then we're going to use the formula a sub n is equals to 1 over a sub 1 plus the quantity of n minus 1 times d. So we're going to find a value. So that n is equals to 10, d, which is our common difference, is 4, a sub 1 is 8. So we're going to substitute 1 over 8 plus the quantity of 10 minus 1 times 4, 1 over 8 plus 9 times 4, 1 over 8 plus 36. So it will become 1 over 44. So therefore, our a sub 10 is equals to 1 over 44. Example number 2. Find the 8th term of the sequence 1 over 3, 1 over 6, 1 over 9, 1 over 12, and so on. The first thing we have to do is reciprocal. So it will become 3, 6, 9, 12, and so on. Then we're going to use the formula again, which is the a sub n is equals to 1 over a sub 1 plus the quantity of n minus 1 times d. Then we're going to find a value. N is equals to 8. D, which is our common difference, is equals to 3. A sub 1 is equals to 3. Then substitute 1 over 3 plus the quantity of a minus 1 times 3. 1 over 3 plus 7 times 3. 1 over 24. So therefore, our a sub 8 is 1 over 24.
Now, let's start out easy with this example. Determine if it is a harmonic sequence. We got 1 half, 1 fourth, 1 sixth, 1 eighth, 1 tenth, and so on and so forth. Now, we find the reciprocal of this sequence. Since if the reciprocal of a harmonic sequence is arithmetic, then it is a harmonic sequence. Now, let's check. The reciprocal of 1 half is 2. The reciprocal of 1 fourth is 4. The reciprocal of 1 sixth is 6. The reciprocal of 1 eighth is 8. And the reciprocal of 1 tenth is 10. Now, an arithmetic sequence has common difference. And since we all know what is a common difference, since it is already explained by other groups, let's check if this has a common difference. 2, 4, 6, 8, 10 has a common difference of 2, plus positive 2, meaning that 1 half, 1 fourth, 1 sixth, 1 eighth, 1 tenth, and so on and so forth is a harmonic sequence. So yes, this is a harmonic sequence. In this example, we want to find the 10th term in the harmonic sequence. 3/5, 3/7, 1/3, 3/11, and 3/13. Now, first of all, we want to find the reciprocal. It's gonna be 5/3, 7/3, 3, 11/3, and 13/3. So the reciprocal is just like the reverse version of the fraction form. Like 3/5, the reciprocal is 5/3. Now, we want to find the common difference first. So, the common difference is 2/3. We simply did it by subtracting 7/3 to the first term, which is 5/3. It's gonna be 2/3. And you might think that the number 3 is out of place, but it can actually, the fraction form is just 9/3, so it's basically the same. So now we got the difference, common difference. Next is we plug it in the arithmetic formula. Yeah. Now, since we already know the arithmetic sequence formula to find the nth term, so we just a sub of 10 is equals to the first term, which is 5/3, plus n minus 1, which is 10 minus 1, multiplied by the common difference, which is 2/3. Now, we subtract 10 minus 1, it's gonna be 9. So a sub of 10 is equals to 5/3 plus 9 multiplied by 2/3. Now, 9 in fraction form can be 27/3. So, we multiply 27/3 by 2/3. So, it will equate to 54/9. 54/9 is 6. So, 5/3 plus 6. Now, we want the 6 to be in fraction form. So, it's gonna be 18/3. Since 18 divided by 3 is 6. Now, 5/3 plus 18/3 is equals to 23/3. Now, the 10th term for the harmonic sequence is we will return 23/3 to the original form, which is 3/23. So that is the 10th term of the harmonic sequence. Now, there is another formula. So the formula is a sub of 10 is equals to 1 over the first term, which is 5/3, plus n minus 1 multiplied by the common difference, which is 2/3. So it's gonna be 1 over 23 over 3. We simplify it, it's gonna be 3 over 23, which is similar to our answer. But I find the arithmetic sequence formula more easier. So, depends on your convenience what formula you're gonna use. So, in this example, we are gonna have fun with radicals. If the first term of the harmonic sequence is 3 square root of 5 over 5, and the third term is 3 square root of 5 over 20, what is the 18th term of the harmonic sequence? First of all, we're gonna find the reciprocal of 3 square root of 5, which is 5 over 3 square root of 5. And we rationalize it, we multiply it by square root of 5, which is gonna be 5 square root of 5 over 3 square root of 25. Square root of 25 can be simplified to 5. That's gonna be 5 square root of 5 over 3 times 5, which is 15. So we simplify 5 square root of 5 over 15. That's gonna be square root of 5 over 3. Now we find the reciprocal of the 3 square root of 5 over 20, which is gonna be 20 square over 3 square root of 5. We rationalize it, with square root of 5, we multiply it. That's going to be 20 square root of 5 over 3 square root of 25. Square root of 25, we know that we can simplify it. We can simplify it, and it's going to be 5. So 3 times 5, it's going to be 15. So 20 square root of 5 over 15, it can be simplified to 4 square root of 5 over 3. Now, after this, we're going to find the common difference. So how do we find the common difference? We are going to use the formula a sub of 3 minus a sub of 1 over 3 minus 1, since it is a sub of 3 minus a sub of 1. It really depends on the nth term of it, what we are going to minus. So we plug it in. That's going to be 4 square root of 5 over 3 minus square root of 5 over 3 over 3 minus 1, which is going to be 2. 3 square root of 5 over 3 over 2. So after that, we are going to cancel it out. It's going to be square root of 5 over 2. Now, since we already have the common difference, which is square root of 5 over 2, a sub of 18, since we are finding the 18th term of the harmonic sequence, we plug it in the arithmetic sequence formula. Square root of 5 over 3, which is a sub of 1, plus n minus 1, n is 18. 18 minus 1, multiply it by square root of 5 over 2, which is the common difference. So we're gonna subtract 18 minus 1, that's gonna be 17. Multiply it by square root of 5 over 2, that's gonna be 17 square root of 5 over 2. So square root of 5 over 3 plus 17 square root of 5 over 2. So first of all, how do we add this? So we're gonna transform the denominator into 6, since it is the common denominator. So we multiply 3 by 2, since that's how we're gonna get 6. So that's gonna be 2 square root of 5 over 6, since square root of 5 times 2 is 2 square root of 5, plus we're gonna multiply 17 square root of 5 over 2 into 3. So it's gonna be 51 square root of 5 over 6. Now, what we added, that's gonna be 53 square root of 5. We're gonna change it back to the original form, which is gonna be 6 over 53 square root of 5. We rationalize it, square root of 5, that's gonna be 6 square root of 5 over 53 times square root of 25, which can be simplified to 5. So 53 times 5 is 265. So the answer would be 6 square root of 5 over 265, making it the 8th term in the harmonic sequence.